All right, so question 2 is saying two boxes are connected by a cord running over a frictionless pulley. The coefficient of kinetic friction between box A and the table is 0.32. Find the acceleration and the tension over the system. So we're finding the acceleration of this system and the tension that is in the rope. Okay, so let's represent our question here. So our box there, then have another box here. So since they've said there's friction, that means there's a force that is opposing the direction of motion, their friction. Then there's mg, which is the weight of the object there. And there's a normal force there, Fn. And there's tension in this rope. Similarly, here on this second diagram, there's tension, and there's weight also, mg, like that. Okay, so let me just check for the data. They told us to say the coefficient of kinetic friction is equal to 0.332. Then we have 100 newtons there and 5 newtons. Okay, 0.32. And this one is 100 newtons. This one here is 85 newtons, like that. So these are the different forces that are acting on our two objects. So what are we supposed to find? We're supposed to find the tension and the acceleration of this system. So this system is going towards the right there, where the 100 Newton box is hanging. So let's apply the Newton's second law of motion on the object that is standing on the table. So if I say summation of forces in the x-axis, because this one only has forces in the y, you can tell, I'm sure. So say summation of forces in the axis, this will be equal to what? Okay, this will be equal to tension, which is positive, subtracting the negative force, which is friction. This will be equal to mass multiplied by acceleration, like that. Okay, so T will be equal to, if you look at summation of forces in the y, there's no acceleration in the y-axis on this object that is on the table, which means the forces of the y-axis are at equilibrium. And what does that mean? That means the normal force Fn is equal to the weight of the object, which is mg, which means the normal force is also equal to 85 newtons. So tension minus, this is the minus, let me do this, okay. Minus, what is the formula for friction? It's mu k multiplied by Fn, which is the normal force. This will be equal to mass multiplied by acceleration. So what is the mass of the object on the table? Is 85 divided by 9.81. I'm getting 8.66 kilograms. So 8.66 kilograms multiplied by A, like that. Okay, so T minus, what is the coefficient of friction? It is 0.32. I put this in brackets, multiplied by the normal force, which is 85. And this will be equal to what? It will be equal to 8.66 A. Remember, this is for the object that is on the table. So I'm failing to write my A here. I don't know what's showing up on the screen. It's having difficulties writing at that area of the screen. Okay, so the value of our force of friction, T minus 0.32 multiplied by 85. Okay, our force of friction has a value of 27.2. This will be equal to 8.66, like that. So that is it for the object that is on the table. So I'll label this as my equation 1. Like that. Now let's check the forces that are on this other object here. You can see to say the tension on this object is against the direction of our acceleration, which means it's a negative force, whilst the weight of this object is the one which is a positive force. So this one, I'll say our weight, which is 100 newtons, minus the tension. This will be equal to mass multiplied by acceleration. So this is summation of forces and the y on the object, that is 100 newtons, like that. Okay, so this will be equal to what? This will be equal to 100 minus t. What is the mass of this object? The mass should be 100 divided 9.81. This will be equal to 10.19 kilograms multiplied by acceleration, like that. And this is going to be our equation 2 right now. So if we have these two equations, you can see that they will also come up with a system of linear equations. So we can solve them together. So I'll say this one. I'll say T is equal to 8.66A plus 27.2, like that. So I'll get this guy and plug it into this other equation. So I'm going to have 100 minus, open bracket, 8.66A plus 27.2. This will be equal to 10.19A, like that. Okay, so 100 minus 8.66A minus 27.2. This will be equal to 10.19A, like that. Okay, so 100 minus 27. This is going to give us minus 27.2, is giving me 72.8 minus 8.66A. This will be equal to 10.19A. So 72.8 will be equal to 10.19A plus 8.66A. Okay, so 72.8 will be equal to 10 10.19 plus 8.66. Forgive, this is giving me 18.85. Hey, I divide both sides by 18.85, then this side by 18.85. It is going to give me acceleration, which is equal to 72.8 divided by 18.85. Okay, so it is giving me an acceleration of 3.86 meters per second squared. All right, so that is the value of the acceleration. Now we can find the tension that is in the string using that equation. Okay, so T is equal to 8.66A plus 27.2. Okay, so tension is equal to 8.66. Where there's A, I'll plug in the 3.86 plus 27.2. Okay, like that. So T will be equal to 8.66A, 8.66 multiplied by 3.86. This is giving me 33.44, 43 rather, 0.43 plus 27.2. 2. So our T will be equal to that. 27.2. Our tension in the string will be equal to 60.63 Newton. Okay, thank you very much for watching, guys. That is our acceleration right there and our tension in the string. Kindly like the video, comment, share, and subscribe to the channel. Thank you very much. Until next time, you can come back so that we continue solving this question.